This video will explain how to use equations to predict the location where two cars will collide. In this example, my two cars, A and B, A has a velocity of 40 centimeters per second, and B has a velocity of negative 20 centimeters per second. The velocity for B is negative because car B is the one that will start at the further position and go backwards. Car A will start at the beginning of our track at 0 centimeters. Car B, according to your papers, will start at 3 meters. However, when I measured my velocity, I used centimeters. So instead of writing 3 meters, I'm going to need to convert that to centimeters. Since there are 100 centimeters in each meter, 3 meters would be 300 centimeters. So my initial position for car B is 300 centimeters. We're going to use this information to write general equations of motion for each car. Our general format for equations of motion is that the position equals velocity times time plus the initial position. For car A, this will look like x equals the velocity, which is 40 centimeters per second, times time, plus the initial position of 0 centimeters. I can simplify this equation since adding 0, we can cross that term out, and this generally just becomes x equals 40t. For car B, following the same process, x equals my new velocity, which is negative 20 centimeters per second, times time, plus the initial position of 300 centimeters. Again, I'm going to simplify this to make it easier to look at, to just negative 20t plus 300. Now, since we are solving a system of equations, one of the strategies we can use is to set these equal to each other. Both equations have x equals on the left-hand side. This means we can very easily just set the two equations equal to each other and solve for the time. So I'm going to write that 40t on the left for car A must equal negative 20t plus 300. To solve this equation, we want to have all of our variable terms on one side of the equation. So to get the negative 20t to cancel out on the right-hand side, I will add it to both sides of the equation. This will cancel out on the right-hand side, and on the left-hand side, 40 plus 20 is 60t, will equal 300. The final step, to get t by itself, 60 times t, the opposite of multiplying by 60 would be dividing by 60. So if I divide by 60, it will cancel out, and I just need to divide by 60 on the other side. 300 divided by 60 will get me 5 seconds. This is telling me the time where the two cars will collide. I have one last part, is to figure out the position where they will collide. Now that I have the time, I can take that and substitute it back into one of my original equations. So the position where they will collide will be equal to the speed of 40 times 5, or 200 centimeters. I now have the predicted time and the position of where the two cars will collide.